Molly, what's up? What? Yeah, just sit right here in the back. Okay. Now, you can go back there. Go back there. Okay. Hey, welcome, guys. If you're not here today, or if you just like watching Roden math videos for your, if you're having insomnia or something, you could watch this video and you'll fall asleep pretty quick. Guys, here's the deal. So, a couple things. I think we got some delta math out there, correct? Right? Okay. We also got page 584 and 562, right? Is that right? Okay. So let's do this. That back there on the board, talk to me about that. Okay, let's do this. Let's make all, what did I say that delta math was due? Tonight. Okay, so let's get all homework. That homework I won't look at, and I won't look at the delta math until tomorrow. Sound good? So I won't assign any new homework tonight. Your job tonight is to clean up all your homework from this class and get it into me by tomorrow. Can you guys do that? Okay, now if it's done, congratulations. You can put it on the top over there. Make sure your name's on it. But I want the homework. You don't have to do it right now, but just get it in. I'm not going to look at it until tomorrow. Sound good? But tomorrow it's going to be late if I don't get it in. Is that fair? Because I think we've had a pretty good heads up on this. Okay, any questions on the homework? Okay, now I know it's been a long time since you've thought about math, but right now we're in the middle of trigonometry. We're going to have our trigonometry test next Thursday. So I'm giving you a nice heads up. A week from Thursday, you're going to take your trigonometry test. Okay, so that gives us a nice chunk of time to learn a few more things about trigonometry. So next Thursday, plan on a trigonometry day. That means I'll try to get the study guide out late this week. Does that sound good? Okay. Any questions? All right. Any questions about just the class right now? Yep. I haven't decided yet. I haven't written the test. So I'll think about it. Okay. Let me see where we're at as far as I'm leaning maybe towards digital this time. Does that sound good?
And it grades it for you if it's
yeah, but so I always like to put an essay question or two in there, so I have to grade. But so I am leaning maybe towards digital. Yep. Okay. Now, so that's kind of where we're at in math. Sound good, guys? I don't know why I'm yelling into the computer. I don't think I need to do that. Okay. All right. So today, we have good things done, and our learning target is, so let me pull this up here. Let me unfreeze my board. So our learning target today is I can use laws of sines to solve problems. Okay, has anyone heard of the law of sines before? So look at that. Everyone's going to learn something new today, the law of sines. So I have a question for you guys. Okay. Can I use trigonometry to solve non-right triangles? Okay. Now, so far, the answer is no, right? Okay. So if I just said, hey, if this triangle right here, I'll put a C. I'm going to erase this C. If I put a C right here, so get out your notes because we're going to take some notes on this today. If I put a C right here, and I'm telling you, and I don't know angle C is right or not, I would be stuck, right, guys? You guys see that? Unless I know all three sides, I wouldn't be able to use the Pythagorean theorem. If this wasn't a right triangle, there's not a lot I could do with this problem, okay? Even if I have numbers or whatever. But something really, really cool happens here. Hey, yeah, close the door. Someone's drilling into the wall here. Okay, so something really cool happens here, and I want to show you this, okay? So first of all, I'm going to go ahead and erase C. It's not that I don't want C, but I'm going to use C will work later, but just pretend for a second we don't have the side angle inside C. So kind of the convention we like to do is we like to do angle, capital A will be our angle, and little a is the side opposite, right, guys? See that? And then we have capital B is the angle, and little b is the side opposite. So if we had C here, this would be C, and this would be little c, right? But here's what I want to do. What I want to do right now is I want to construct an altitude right here. So I'm not going to have a right triangle, but I'm going to make an altitude. So now I can actually use some of my trigonometry here. Okay, thanks, Xavier. You can go. So go ahead and draw that in. I'll give you guys a second to draw this in. Okay. Now, I'm just going to call this H for height. Okay. Now, H is not actually part of the triangle. H is not a side of the triangle. H is an imaginary distance between the vertices and the vertex and the opposite side, right? So that's going to be my height. Now, let's go over to A. Okay, let's look at angle A for a second. How could we, now remember, and we should always do this, we should always talk about TOA when we're doing this trigonometry stuff, right? So how could we, let's look at angle A for a second, okay? If we look at angle A and we want to do a SOHCAHTOA here, I could get A, H, and B in a SOHCAHTOA kind of a sentence. I wouldn't have any information, but I could write a trigonometry equation using angle A, side H, and side B. You guys see that? So what could I do? Which SOHCAHTOA would I use if I wanted to get angle A, H, and B in one equation? I'd use sine, right? Because remember, what sine? Opposite over hypotenuse. Okay? So what is the sentence that I could write here? Someone raise their hand. What could I write, Tanner? We could write the sine of A equals H over B. Does everyone see that? Okay. Any questions on what I've just done there? All right. Now, the next thing I want to do is let's do the exact same thing, but now let's come over and use B instead of A. What could I write there if I wanted to use B, H, and A now? What could I do there? Sine of B equals H over A. Now, here's the deal. What do you notice both of those equations have in common? What thing do they both have in common? They have an H. So let's solve for H. Okay? So let's get H by itself. Okay? How could we get this H on the left side by itself, class? What could we do? I want to solve for H. Sophia, what could I do? Correct. I could multiply both sides by B. So do this with me. So now we got this. I'm going to kind of flip it here. I've got H equals B times the sine of angle A. You guys see that? Now, I can solve over here, ladies and gentlemen, for H, right? Again, here. So what would I do? I know Sophia has this, so someone help her out here. Someone add to that. What could I do to get this other equation solved for H? What could I do? What could we multiply both sides by? By A, right? Okay, now when we do that, this one is going to be H equals, because these A's cancel, right? H equals A times the sine of B. Okay. See what I have here? Now, so why did you do this, Mr. Roden? If they're both equal to H, then we can set them equal to each other. That's substitution, right? Okay, see that? If H equals B sines of A and H also equals A sines of B, we can set them equal to each other. So we can say that B times the sine of A is equal to A times the sine of B. Okay. Any questions? Now we're almost done. We're just going to do one other thing. let's just get sine of A by itself. How could I get sine of A by itself without the B? What could I do? I could divide both sides by B. Okay? And let's say I want to get sine of B by itself. How could I get sine of B by itself? I could divide both sides by A. So if I multiply both sides by AB, what will that do? Well, on the left side, it's going to cancel out the B's. And it's going to leave an A in the denominator. You guys see that? And on the right side, the A's are going to cancel out, and you're going to get B in the denominator. So what do we have? Well, we've got the law of sines, guys. This is what we have here. So sine of A over A equals sine of B over B. Now, if we had C also in this mix, we could do another height, and all that. So I'm just not going to do C, but what do you think C is also going to be if we use C? So sine of C equals sine of C over C. Guys, this is the law of sines right here. This is your law of sines. Now, why do we like the law of sines? Because if you given now you have to be given certain information. You can't just always use the law of sines on any triangle. But we're going to see that we can actually solve triangles today that aren't right triangles just by using these proportions or these fractions. Now, another thing is you're not going to have three at the same time. You're always going to have two of the three, okay? So I know I put all three in there. You're not going to have all three. You're only going to have two. So here's how the book has it. There's the law of sines right there. That's probably a better way to write it down. So that's the law of sines right there. Okay, so I'll give you a second to get that out pretty into your notes. Very, very, very nice rule. Okay, and notice it. The cool thing about it is you can solve a triangle without having it to be a right triangle. Okay. But you cannot just willy-nilly just have one. First of all, you have to have information, right? Some informations, the law of sine works, and some informations on triangles doesn't. Okay. So there's different triangles you could, so on a triangle, you could have, we'll call this case 1. Okay. Case 1, we'll call it the side, side, side. Okay. Side, side, side would be that you have A, B, and C given to you, those numbers. You guys understand that? So A, B, C are given. So you know the values of A, B, and C. That would be the case of side, side, side. Now, don't think about it like proving triangles correctly. Think of it as information given. So it's a little different than proving triangles. So don't think like side, side, side as a triangle proof. Think of it as what information do you have. On this triangle, you're given A, B, and C, and you don't know anything about the angles. You guys understand that? Okay. Case number 2 is what we could have. We could have SAS, side angle side. Well, what does side angle side look like? Well, side angle side would mean that you have side A, angle B, and side C given to you. Side angle side. Does everyone understand that? So side A and C are given, and angle B are given. Okay? You guys with me on that? Okay. We could also have case 3. Case number 3, we could have angle side angle. Angle side angle. Okay? So what would that look like? We could have, again, we could have an angle A we could have side B and angle C given to us. No, hold on. That is, this is, yeah, angle side angle, right? See that? Okay, so that's case 3. Now there is, and then there's case 4. Okay, so there's actually 5 cases. Case number 4. Okay. Case number 4 is, what do we have? Angle, angle, side, right? Now, angle, angle, side is just a derivative of angle, side, angle, right? But so we could have angle, angle, side. So we could have an angle, another angle, and then we could have a side. Angle, angle, side. That'd be little a, right? See that? Now, there is actually a bad word here that we could use. Now, the bad word actually kind of works sometimes. So this is called the ambiguous case. Ambiguous case is kind of a pain in the, it's like sometimes you could have none, sometimes the law of sines will work, sometimes the law of sines will not work, and sometimes the law of sines will give you 2 different answers. Okay, so this is called, and we don't want to use a bad word, so we're going to say SSA instead, right? We don't want to use a bad word. Okay, so in this case, the ambiguous case, we're going to call this side, and then an angle over here. See that? And that's the ambiguous case. Ambiguous, do you guys know what ambiguous means? George, you like, what does ambiguous mean, George?
Well, it's left kind of vague. It's not certainly one thing. It could be one thing or another.
It's not certain. It could be one thing or another. And that's not good. It's not good to be ambiguous in mathematics. Do you guys understand that? So right away, we don't like that, but we can. It's going to require us to do more work. Okay, so here's the deal. These are all the possible things we could have when we're given information on triangles. We could have side, 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 SAS, ASA, and angle, angle, S. Okay? And the ambiguous case, side, side, angle. Or you want to make a bad word out of that, right? We don't want to do that. Okay, so which ones does law of sines work with? It works with angle, angle, side, ASA, and it works with SSA, but that's the ambiguous case, okay? So here's what the ones we want to do. So it works with angle, angle, side, or angle, side, angle. Okay, you guys see that? So the big ones that we're going to work with today is we're going to be working with these guys. Angle, side, angle, and angle, angle, side. If we have that information, we can solve the entire triangle. Now, the ambiguous case we'll look at tomorrow. Okay? This we're going to just put off. My opinion is do the easy stuff first and then save the hard stuff for the next day once you have the easy stuff down. Does that sound good? Okay, so here we go. So let's do some examples. Okay. All right, so draw this down and let's call this example number 1. Okay. So if you notice here, if we had this triangle class, we would not be able to do this. Just if we couldn't solve this triangle. Remember what we mean when we're solving a triangle. We're solving a triangle by finding all missing sides and all missing angles. So it looks like on this triangle, in order to solve it, we're going to need to find an angle and 2 sides. Okay, and obviously we could not use the Pythagorean theorem on this because, well, it's not a right triangle, right? Now, I will say this. It will also work on right triangles. Okay, so there are, right triangles, basically I'm saying the law of sines is going to work on any triangle if you have given the right information. It could be a right triangle. It could not be a right triangle. It doesn't matter. Okay, so first of all, what case did I just give you here, class? What case did I just give you? So I gave you angle, angle, side. Now, Xavier, why do we have angle, angle, side here? We got two angles and a non-included side. You guys see that? That's angle, angle, side. Okay, so that means we can use the law of sines. Do you think if I just have side, 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 you think I'm not going to have any problems with side, side, side? You guys understand that? Because it can't use the law of sines on side, side, side. We can use the law of cosines, though. But we'll do that later, right? Okay, so here we go. Let's do this. So first of all, let's call this. Now, just for the sake of fun, I'm going to call this A and little a, just so we can fit it into our definition. I'm going to call T, I'm going to call this C, and I'm going to call this little c, okay? And I'm going to call this B, and I'm going to call this little b. Now, you don't have to keep doing that, but in order to use my law of sines, it might just be nice to just switch it right away. That way we can put it in here. So remember, what is the law of sines? It's sine of A over A equals sine of B over B equals sine of C over C. You guys see that? So what we want to do is we want to use two of these things, and we want to have everything except one missing value. Okay. Now, right away, before we use the law of sines, can we figure out one piece of missing information just using good old-fashioned geometry skills?
Yes.
Awesome. What could I do?
35 plus 38, and then that minus 180. I would guess 100.
Okay, so Austin's kind of mumbling over here, but I hear, what is that? What is that? So you take triangle angle sum theorem, right, guys? Add them up, subtract from 180. And what is that number, Xavier? You have the calculator? 10. So that's 107. So right away we could figure out the missing angle. So that's not all that informative. So now let's go ahead and figure out. We got to find some sides here. So here's the first thing you want to start out with. You want to start out when you have an angle and an opposite side that's given to you. You guys understand that? So which pair, A and A, B and B, or C and C, has both pieces of information? A and A, right? So we could do A and A. So we could use this one. All right. And then we want to find another one where we're just missing one of the pieces of information. Which ones could we use there? It doesn't matter. We could use B or C now, right? You guys want to use C? So we're going to use these two proportions, these two fractions. Okay, so here we go. So instead of a sine of A, we could say it's the sine of what, class? Sine of 35 over the opposite over 15 equals, now let's do sine of C. What is the sine of C? 107 over what? Over C. So now if we have one variable, we can always solve an equation with one variable missing. Okay? Well, the first thing I'm going to do is I'm going to get C by itself. There's a lot of things you could do. I'm going to cross multiply here. Do you guys see these are proportions? I'm going to cross multiply them. I'm going to what we call butterfly it, right? So this is going to be C times the sine of 35 equals 15 times the sine of 107. You guys see that? Now, remember what I'm trying to do here. I'm trying to find C. So what could I do next, guys? How could I solve for C? Sophia, what can I do? Divide both sides by the sine of 35. Very good. Divide both sides by the sine of 35. Excellent. So now we have this down, and this is actually a number because it's just numbers. C equals 15 times the sine of 107 all over the sine of 35. Okay, so now I want you guys to get your computers out, get your calculators out, pull up a Google calculator or whatever, and then I want you guys, remember, make sure you're in degrees, not radians. And now what I want you guys to do now is I want you to calculate this out, and we'll round to the nearest tenths place. Okay, so go ahead and do that. So Xavier has an answer. We're going to have him hold off, though, and I want you guys to be able to do this in your computer.
almost like they're both calculators. Yeah, you're going to get the same answer if you use calculator.
Well, they're just... All right. All right. So who had now? Just looking at this thing, I know this thing has to be longer than 15. Do you guys understand why? It's got to be longer than 15 because it's opposite a bigger angle than A. So it's got to be 107 is bigger than 35. Therefore, it must be bigger than, it has to be, yes, this would be bigger than both of them, right? Okay, what do we got?
25.
Okay, I'm hearing exactly?
No,
Basically.
with rounding, it's 25 no matter what.
Okay, so 25, we're going to call it good. How many got that answer? Just show of hands. You got 25 there. Okay, good. All right, now let's go ahead. So if we have this triangle, this is getting kind of messy here. Now let's go ahead and do law of sines again, but now we need to find B, right? Now, I would highly recommend not using C because then you're going to be using a rounded answer, even though, okay? So I would go, let's find, let's maybe do these two right here. Does that sound good? I always start out, this is kind of the key. I always start out there because that's what I have. All right, so what would be my equation I'd write there, guys? What would I do? So sine of A, which is sine of 35 over 15. So it'll start just like what we did before. And then what will the next part be? Sine of 38 over what? Little b. Now, what will we know about little b? Before we do anything, just so we know we get a reasonable answer, what do we know that little b has to be between? So it's got to be greater than something or less than something. What does little b have to be greater than, class? It has to be greater than 15, right? What does little b have to be less than? 25, because remember, the opposite side lies opposite the greater angle, right? The larger the angle, the greater the side. So it's that whole thing. So we know it's got to be in between 15 and 25. Well, who cares, Mr. Roden? Why are you saying that? Well, you know, if we get a weird answer in our calculator, then we know we did something wrong. If we get a number between 15 and 25, we know we probably did the right move here. See that? Okay, so what are we going to do to solve this equation algebraically, guys? What are we going to do first? How about cross multiply it? Sound good? Want to cross multiply? Let's cross multiply this. Give myself some room here. Okay. All right. When we cross multiply, what do we get? Well, we get b times the sine of 35 equals 15 times the sine of 38. Okay, see that? And then what are we going to do next to get b by itself, guys? Divide by the sine of 35. Okay, awesome. Okay, so what do we get what does b equal, class? 15 point what? 16. Does that seem like a good, reasonable answer? Yeah, perfect. Yeah, we know it's got to be a little bit larger, but not much, because 38 degrees is not much larger than 35. So yeah, 16.1 seems like a really reasonable answer because 38 is just a little bit bigger than 35. You guys see that? And we're done. So law of sines is pretty cool, right? All right, so let's see if you guys can do it on your own. No, we don't want that one. Side angle side. What do we want? Yeah, this one right here. This one's good. Okay. So what do we have here? We have another angle side problem, correct? So this one should be a doable problem for us. Okay. So I don't want to do the ambiguous case today because that's kind of heavy. But today we're just doing good old fashioned.
Really?
Yeah, yeah.
Good job. Go.
Okay. So, what's the first step? So maybe we could label this stuff out, right? So what should I put with the 80? What should we call that? So that's big B, right? What should we put with the 50 here? What? C. And what should we put over here? Big A? All right. So, law of signs. Start me out. What are we going to do? I always like to start out with the given information that I already have.
Angle, big A's angle is 50.
Big A's angle is what?
50.
Is what?
50.
That's 50 right there?
Yes.
All right.
And
So now we already know that what?
Little A's 10.
Little A's 10. And why do we know that? Isosceles triangle theorem, right? Yep.
Oh.
So in this case, we can use what we already know here. So that's good practice. So you could have figured it out and you get 10, or you could say it's already 10 because those two base angles are congruent, right? But we don't know B though, right?
Yeah.
But we can. So help me out. How can we use the law of sines to figure out B? What could we do? Tanner, help me out. Go. Sine of what? Sine of 80 over B
The sine of 50
over 10. Okay. Keep going, Tanner.
Oh, okay. And then you could cross multiply.
So if I cross multiply, what do I get?
B sines of 50.
So I get B sines of 50 equals what? 10 sines of 80. Okay, keep going, Tanner.
And then you would divide by the sine of 50.
Okay. And then what do you get? B equals what?
Round to the 10th place, you get B is about
12 point what?
12.9.
Guys, does 12.9 sound like a pretty reasonable answer? Yes, that sounds good. Yep. Okay, cool. All right. What else do we got here, class? Let's see here.
Yeah, let's do that one.
So let's see. Could we do this problem right here? So this is what? This is side angle side, right? Now, we've talked about this was not on our case that we could use, right? But maybe I'm wrong here. So let's call this A, little a, B, little b, and C, little c, right? Okay. Now, could I use the law of sines here? Well, what could I do here? I could do, if I did sine of A over A, that is going to be equal to sine of 60 over A, right? Now, is this a 3, 4, 5? So they're saying that this, I don't know. Okay. All right. So, well, you don't know that's a 5, right? You don't know it's a 5 because you don't know it's a right triangle, right? Yeah, Esme. 4 is B. Sorry. Okay. So we got sine of 60 over 5, right? Hold on. A over, nope. 60 over A, right? Okay. So let's see here. Sine of B over B. Well, sine of B, we don't know, right? So that's sine of B over 4. Is that right? And then sine of C over C is going to be sine of C over 3, right? And you guys see why that's an issue here?
Yeah.
Do you see why law of sines doesn't work for side angle side? You guys see that? So side angle side. Now, we may be able to get side angle side into another way, but this way doesn't work, okay? All right. So it does work with angle side angle. So let's say that you're given, let's do another triangle. Let's see if I can do that. So let's say you're given this guy right here. Okay, so you got this triangle. Okay, so let's say, so it works with angle side angle. So let's say that this is a 28-degree angle right here. You guys see that? And let's say this side right here is 9 centimeters, or just 9. We'll just say 9. We'll put it. And let's say this angle right here is 112 degrees. Okay. And we'll call this A, B, and C. So it's saying we can use this. So your job, ladies and gentlemen, is to go ahead and solve this one for me. Okay, so this one is angle side angle.
Is this going to be on our test?
Absolutely.
Oh,
Yep. Everything we're learning since trigonometry will be on the test, right? But we'll go through and review it all. So with spring break in the middle of it, But yes, absolutely, this is on. Yep.
Is that better?
Pull. How's it going? Yeah. Hey, Sam, can you prop our door open again? So
Yes, sir.
it's kind of a fire hazard. All right. Now, I'm not going to go through this whole thing here. Okay? What I'm going to do is just have you guys list the answers out for me, okay? So when you think you have it. Now, angle A, that's the first thing you need to tell me. Tell me angle A, and then I need, what do I need here? I need little b and little c, right?
Oh, you're right. My bad.
Okay, so, Will, what is angle A?
I got 40.
You guys agree 40? Okay. So Will says 40, and it sounds like we agree with him. Will, call. We're gonna play. You pick on someone else. The next person. Will, you tell me the next. Who do you want to answer? Let's go side A.
Xavier.
Xavier, what'd you get for side A? 9. Oh, sorry. Let's do. What do we need? Sorry, side B. My bad. I thought that was an A. Sorry. Yep. Yep. B. What'd you get? 6. Xavier got about 6.6. 6.6. You guys agree with that?
Yes.
Okay, now, and would that make sense? It would make sense because it's got to be smaller than the 9, right? So it's a good chunk smaller. So I think 6.6 seems like a good, reasonable answer. All right, what about C? What's little c? Xavier, calling someone. Caitlin. What'd you get? About 13. How many agree with 13? And that seems about reasonable because it's the longest side there. Okay? Guys kind of see the law of sines? Does that kind of make sense?
Yeah, but no.
Okay. So where are we going from this? So what we have to do next is tomorrow we have to look at the ambiguous case, okay, of SSA. Okay? So we have to look at the ambiguous case of SSA. We're going to see how that works. And then after that, we're going to move into law of cosines. Law of cosines. Law of cosines, yeah. There is, yeah, you can turn all your papers in. There is no law of tangents, though, unless, as far as I know. I've never heard of a law of tangents. Okay, I'm going to end the video now, and I'm going to post it. So, awesome.